Dear students, so far in the subject of high voltage engineering and switchgear and protection, we studied high voltage part. From this class onwards, I will be dealing with power system protection part. So let us start with the importance of protection system in a power system. Here I have shown a very simple power system for understanding purpose. Here is an alternator, or you can call it as generator, and step up transformer at generating station. Let us call it as T1. Step down transformer at receiving station, and we are having here transmission line. In actual power system, there will be large number of generators, large number of transformers, and large number of transmission lines. And to construct such a power system, lot of money is invested. Therefore, an electric power system should ensure the availability of electrical energy without interruption to every load connected to the system. So what is the requirement here? Requirement on power system is power system should ensure the availability of electrical energy without interruption to every load connected to the system. Power system consists of several thousand kilometers long distribution lines and several hundred kilometers long transmission lines. These distribution lines and transmission lines are overhead lines and are exposed to the environment. Therefore, there are chances of their breakdown due to storms, falling trees, birds, etc. Also, the insulators may be damaged due to lightning strokes. These can result not only in mechanical damage but also in an in an electrical fault. One of the sources of trouble to continuous supply is the shunt fault or short circuit, which produces sudden and sometimes violent change in system operation. Hence, to protect the components of power system against the damage that would occur due to fault a protection system is necessary. So to protect the components of power system against the damage that would occur due to fault, a protection system is necessary for a power system. Now we should understand how a protection system works. It consists of relays and relaying systems that detect abnormal conditions like faults in electrical circuits. In our case, it is power system, and operate automatic switch gear to isolate faulty equipment from the system as quickly as possible. So the function of protection system is to detect any abnormal condition like fault in electrical circuit. In our case, electrical circuit is power system, and operate automatic switch gear, for example circuit breaker, to isolate the faulty equipment from the system as quickly as possible. See, if the faulty equipment is not isolated from the healthy power system part In that case, the fault current would flow in the power system for a long time and it would cause damage to the other parts of the power system also. Hence, it is very much essential that a protection system operates very quickly. Remember here, a protection system will only detect the fault when it occurs, but not in advance. It is not possible for any protection system to detect a fault in advance. Only after occurrence of the fault, the protection system detects it and it isolates a faulty equipment from the system as quickly as possible. If we had a protection system that would detect fault before its occurrence, then there would not have been any fault in the power system at all. But such systems are not there with us at present. But if a minor fault develops into a major fault, then by detecting the minor fault, we can prevent the major fault occurrence and protect the huge loss that would occur because of the major fault. Let us see a very simple protection system. Breaker means circuit breaker here. It is CT for measurement of line current, and here we are having a capacitive voltage transformer for measurement of voltage at certain point on the transmission line. It is relay here. The measured current and the measured voltage are given to the relay for the purpose of detecting presence of fault. For the operation of relay, certain power is needed and that power is fed by using a battery. When a fault occurs, the relay issues a trip signal to the circuit breaker. Upon receiving trip signal from the relay, the circuit breaker gets opened. For time being, you understand the circuit breaker operation in this way. Say this is transmission line and these are the contacts of circuit breaker. Closed circuit breaker it is. Out of these two contacts, one contact will be fixed and another one will be movable. When a fault occurs and the trip signal is issued to the circuit breaker, the movable contact moves away from the fixed contact. That may be shown like this. Say this contact has moved away. Now the circuit breaker is open. So when the circuit breaker operates, the contact surfaces get separated and the current flow ceases. That is, faulty equipment is isolated from the healthy part of the power system. So let us show here capacitive voltage transformer. CVT is capacitive voltage transformer. Which we studied in high voltage engineering. CT is current transformer. And this is transmission line. Next we will take up zones of protection. The protected zone is that part of a power system guarded by a certain protection scheme and usually contains one or at the most two elements of the power system. By reading this, you will not understand what is actually the protected zone is, but when I draw the figure and show you the zone of protection, then you will understand it very clearly. I will consider one power system having two generators. First generator the second generator. Resistive grounding is used for both the generators. And here are the generating station transformers, which are usually step-up transformers. And the two generators operate in parallel and feed their power to a common bus. Bus is nothing but a thick conductor which operates at constant voltage. You can see here circuit breaker, and this bus is connected to a transmission line operating in parallel with another transmission line. So those two parallel transmission lines are shown here. Here also we will show two circuit breakers. Near next bus we will show one more circuit breaker in each line. And here are, say, low voltage lines. Let us show circuit breakers in these low voltage lines also. Now generator and transformer are to be protected against any fault occurring in them. So we'll show here one dotted box which is nothing but zone of protection for generator 1 and transformer and also the circuit breaker here. Similarly, we will show here one more zone of protection for generator 2, transformer and corresponding circuit breaker. Now, within this dotted box, if a fault occurs anywhere, then the protection scheme associated with the generator, transformer and circuit breaker will make the circuit breaker to operate, and the generator and transformer will be disconnected from the healthy part. Similarly, here also. Next, bus bar is to be protected against any fault occurring on it. So, we will show here one zone of protection for bus bar. If any fault occurs on the bus bar, then that bus bar must be disconnected from both generators and also the transmission lines. So, the protection scheme associated with the zone of protection shown here for bus bar does that job. Next, we have to show protection zone for both transmission lines operating in parallel. Now these two zones are the zone of protection for two transmission lines. Again we have to show zone of protection for next bus, this way, and then for the low voltage line here. So this is generator, transformer, zone of protection. This is bus bar zone of protection. These are transmission line zone of protection. This is bus bar zone of protection. And these are low voltage transmission line zone of protection. You can call it as high voltage transmission line zone of protection. You can see here the zone of protection of transformer and zone of protection of bus bar are overlapping. Zone of protection of bus bar and zone of protection of transmission line are overlapping. Similarly here also, zone of protection of high voltage transmission line and low voltage transmission line are overlapping. This overlapping ensures that each and every component of the power system is protected. If any part of the power system is not protected, that is, if there is no overlapping, then the part of the power system which comes under not overlapped, that is, the part of the power system which lies in not overlapped if there is no overlapping between any of the zones, then certain part of the power system would remain unprotected, which is not desired. And such unprotected part of the power system is called as blind spot in the power system. The zones are arranged to overlap. so that no part of the system remains unprotected. Figure above shows a typical arrangement of overlapping zones of protection. If for economical reason zones of protection are not overlapped, then some part of power system remains unprotected. Such unprotected part of power system is called blind spot. It is so called because it will not be visible for the any of protection scheme implemented. Let us consider a transmission line here and two zones of protection, namely zone A and zone B. I have considered point X on the transmission line. To the left of X point, the two zones are overlapping here. But to the right of point X, there is no overlapping of the zones. Only zone B is protecting the transmission line here. If here is a circuit breaker, in case of fault at X, zone B protection scheme will detect the fault and the circuit breaker will operate. That means there will be discontinuity in transmission line and hence no current flows to point X from the right side, but from the left side of this point X the current will flow into the point X, though there is a fault. That means zone A is not detecting fault occurring at X, and hence this X becomes the blind spot in the power system, as there is no overlapping of two protection zones A and B. Dear students, I will stop the class here and continue in next class with requirements of a good protection system. Thank you.